Hello once again, class, and welcome to another mock lecture. Today we're going to be tackling the 5-number summary. We're going to start off talking about measures of center. So suppose you're given some data set. Looks like this, 7, 3, 11, so on and so forth. I'm not going to read all that. There's 14 data points here. That's the important part. And you might ask yourself, what is the center of this data? Well, it turns out there's 3 different ways that we could define the center of some data set. The first is probably the one we're most familiar with, which is the mean, or the arithmetic average. And that's simply just the ratio of the sum of numerical data divided by the number of data entries that there are. So you take all the numbers, add them all together, you divide them by the number of data points that there are, which in this case is 14, and you get 16.64 approximately. Right, I rounded that a little bit. Okay, but there's 2 other ways you could measure center. One of them is called a median. Right, the second way to measure a center is a median. And a median is literally the middle value of a sorted data set. Sorted meaning that you have to order your data set typically from least to greatest, but you could go from greatest to least technically. But in any case, because it's the middle, right? So it doesn't matter which way it's ordered. But in any case, you have to sort your data first. If you're using a spreadsheet like Excel, that's relatively easy to do. But if you're doing things kind of by hand, then it is a little cumbersome. But in any case, the middle of this data set is literally the value that's in the middle of the set. The problem is, depending on how many data points you have, the middle is kind of different. If you have an odd number of numbers, right, in your data set, then there is literally a middle number. Like, for example, this data set here, 8 is literally in the middle of the data set because there's 3 numbers to the left of it and there's 3 numbers to the right of it. And so the middle number, 8, is the median. But if you have an even number of entries, like we do here, right? We have an even number of entries here, then what you have to do is you have to find the middle 2 values, and then you find the mean of those middle 2 values. It means you find the average of those middle values. So here I split the data set into 7 values. There are 2 middle numbers, 11 and 15. And what we do is we average those things. So we add them together and divide by 2, just like we're finding a mean between 2 numbers. And so 13, right, is the median of this data set, which is interesting because 13 is not actually a value in the data set. So it is possible to have a center that's not actually a value in the data set, and it potentially could happen when you have an even number of data points. I say potentially because, maybe you have 5 things here, and then the number 7, and then the number 7 again, and then 5 things here. So your middle number, so you have 12 numbers in totality. You have 2 middle numbers, but when you average these things, you get 7. And so technically 7 is the median. You can't point to it and say, oh, this is the 7, right? That's in the middle. We just say 7 is the median. But 7 is actually also a data point. But it's important to know it's not this data point. And it's not this one. It's the kind of hypothetical average. I mean, it's not hypothetical. I guess it's literal. But it's the average between those things. And that average is not technically part of the data set itself. And that's what this note says. It's likely not a data value. You can't point to it and say, oh, that's the median right there. The third way that you could find a center is with something called the mode. And a mode is just the data value which appears most often in the data set. So it's the most frequent number. In our case, it's 7 because it appears 3 times, and that's the most frequent number that exists in this set. You can have a data set that has no mode. Like if I were to get rid of any of these repetitions, like say we got rid of 24 and 2 of the 7s, I don't think now there's any repetition of stuff, and so this data set would have no mode. But it is also possible for data sets to have more than one mode, right? You could have something that has 2 modes, in which case you'd have a bimodal set. Like this. If we got rid of the 7, one of the 7s rather, then we have 2 modes, 7 and 24. If you have 3 modes, there's 3 numbers that appear the same number of times, and it's more than any of the other numbers, then that would be called trimodal. So these are the 3 ways that you could measure center, and kind of how I define these things in my own words. This one's just the average data entry value. This one's just the literal center data value, and then this one's the most frequent data value. And we would count the mode as a center because you might say, how is this the center? You might say, Mark, how is this the center of the data set when it appears all the way to the left? And I would say, well, look, when you actually graph a histogram of this thing, that's the tallest that's the most frequent bar, right, on the histogram itself. And so that is kind of like the center of your data because that's where most of the data is falling in and kind of everything, it kind of encapsulates that. I don't know if that makes sense, but it does to me, and that's what's important. I'm just kidding. I actually hope that makes sense to you. Now, the thing that we don't get, right, from these centers is how is the data spread out around, right, the center, right? Like we don't have any information about the spread. And to kind of belabor my point, this set right here, right, this data set has the same mean, median, and mode as this set. But look how much different the data set is. It's literally 13 sevens, I think is what's listed here, and then 132. But it has the same median, it has the same mode, and it has the same average. If I average all these things, I'm still going to get 16.64, right, for all of those things. But they're just by looking at them, we could say, no, these are drastically different data sets. Okay, so how can we account for the spread of data? Well, one way that we can do that is looking at how the data is separated in what these things called quartiles are, in 25% chunks of data. That's how I think about what a quartile is. And we can do this by describing a 5-number summary. We use 5 numbers because we need 5 numbers to split data into 4 pieces, right? Here's one piece, here's a second piece, here's a third piece, and here's a fourth piece, right? It's the data that's in these kind of containers, if you will. And so that's what we're doing. This is like quartile 1, quartile 2, quartile 3, quartile 4. And these points, right, these data values are what's splitting the data into these 25% chunks. So there's 2 things to keep in mind. One is that you have to remember the number of things in each quartile is always the same for all of them, right? It's always 25% of the data. The second thing, I don't know. I lost my train of thought. There's only one thing to keep in mind. Every quartile has the same number of things in it. If I remember what I was going to say, I'll say it to you. But anyway, here are the 5 numbers. There's the minimum value. There's the first quartile value. There's the median. And we already know what the median is. We know how to find that. There's the third quartile value. And then there's a maximum value. So kind of these 3 you get, I'm not going to say for free, because if you have to order the set, there's some amount of work that goes into finding the median. And I guess minimum and maximum as well. But you don't have to actually like calculate anything to find the minimum and the maximum. And I guess if you have an even number of things, you would technically have to calculate the median and count where the middle number is. But those 3 things you can get by just kind of looking and ordering the data set. But again, these are the values that we're going to use to be the boundaries of each of the quartiles. So there's 25% of the data between the minimum value and the first quartile value. There's 25% of the data between the first quartile value and the median, right? So on and so forth. I put an asterisk next to median because to remind you guys, you have to sort the data to find the median. But then also some textbooks will call the median the 50th percentile. So keep that in mind. If you ever hear someone talk about the 50th percentile, they're talking about the median of some data set. So, okay, how do we find these other things, right? We know minimum, median, and maximum are relatively straightforward enough to find, but how do you figure out what the first quartile value is and what the third quartile value is? And as it turns out, those things are also medians. The first quartile value is the median of the lower half of the data. And I put also there that you don't want to include this median in the lower half of the data, right? Whether or not there's an even number of data points or an odd number of data points, the median is splitting the data and it doesn't belong to either the first or second half, the lower or upper half of the data. And that means that the third quartile value is also a median, but it's just of the upper half of the data. Again, not including the median. So let's look at an example of how we can find a 5-number summary to describe the spread of some data. All right, example number 1. Find the 5-number summary of the data set that we've been using this whole time. So it's the same data set. We already ordered it, so I'm just going to leave it as an ordered data set here. And we need to find 5 numbers. The minimum and the maximum are just the leftmost and rightmost numbers respectively. And we actually already calculated the median to be 13 here. So we'll just go ahead and jump to this stage of the 5-number summary. We just need to figure out what's the first quartile and what's the third quartile. Well, like the median does, it splits the data in half. There's 7 numbers in the lower half and there's 7 numbers in the upper half. Because 7 is an odd number, we can actually just count to find what the middle number is in both of these cases. In the lower half, 7 is the median, right? There's 3 numbers to the left of it, there's 3 numbers to the right of it, and so that is going to be our median. That's the first quartile value. I meant to put value here. Pretend this says first quartile value. It's not the first quartile. The first quartile is not 7, but the first quartile value is 7. Same with the third quartile, which is 25. Because again, 3 numbers on the left, 3 numbers on the right. And so here's our 5-number summary. It's this thing. To which you might say, cool, right? Like, how this doesn't really help me figure out what the spread of the data is. These are just numbers, right? How does this help? Well, you actually have a point, right? If that's the boat that you're in, because you're right, they're just numbers. Like, spread is mostly relative, or maybe visual. And fortunately for us, there is a visual way to help us see these quartiles a little bit easier, and that visual is called a box and whisker plot. And it's not even that hard to draw. You actually just base it directly on the 5-number summary. Remember that thing I was doing before? I was like, we draw these kind of lines, and then, we have 5 of them, and that separates data into 4. I'm not going to say equal because their spread is going to be different, but all 4 pieces have the same number of things that are inside of it. That's basically a rudimentary box and whisker plot. So what I'm going to do is I'm going to draw a number line, right? That's this thing here. I drew this number line. And above it, I'm going to draw some vertical lines that represent these 5 numbers. So I drew a vertical line at 2, and then I drew a vertical line at 7, and then I drew a line that went between them, because there has to be some artistic flair in the box and whisker plot. This is the whisker part of the box and whisker plot, if you will. And so what we're saying is 25% of the data is in this first kind of section of the box and whisker plot between the numbers 2 and 7. There is a little bit of nuance that's going on with how I'm labeling stuff, and the convention is if the actual value of one of your vertical lines doesn't show up on the actual number line, then you should put it in yourself, right? You don't want the reader to look at this, pretend this isn't here for a second. You don't want the reader to say, oh, it's between 6 and 8, so 7, right? When, maybe it's like 6.8 or something like that. So you always want to label the things that aren't exactly on the number line itself. So I labeled 7 here. Then I drew the median, right? The median's over here at 13. 13 also not a value on the number line, so I'm just labeling it here. And instead of just drawing a horizontal line that connects these two things, we draw the first box of the box and whisker plot. Now, there's a lot of different textbooks that do a lot of different things for box and whisker plots. Some textbooks don't shade in the first box. You don't have to shade in the first box either, but you have to admit, if you're not shading in the first box, do you really care about how your box and whisker plot looks? I don't know, that's just me. I like to make it look kind of artsy, and so I like to fill in the first box of the box and whisker plot. But this first box, this shaded in box, again, represents another 25% of the data. That is our second quartile, right? So quartile 1 is this thing here. This is now quartile 2, right? It's this thing here. Next, we fill in the third quartile value. By the way, that was the median. I don't think I said that, but we graphed the median right there. This one, though, this is the third quartile value. And again, we're going to draw a box. This one, I don't shade in, right? To show there's a distinction, right? And, maybe you want to actually flip it. Maybe you want your first box to be not shaded and your second box to be shaded. Maybe you want neither box to be shaded. Maybe you want both boxes to be shaded. I mean, it's really up to you kind of at this point. I should also mention, just because I'm thinking about it, some textbooks don't even use lines. They use like a dot, and then they'll draw their first box, and then they'll draw their second box, and then, maybe their last quartile is really spread out, and they draw their last dot like this. I like the lines personally, but I'm just showing you there's some variation in the way that these things are drawn. And then anyway, finally, you have your maximum. Right, and I put that over here. Notice I didn't label this one because 36 is actually on the number line. But that's our last 25%. That's our fourth quartile, as it were. And so this is way more useful, I think, than something like this, right? Because we can actually see the spread of the data. You can actually say, hey, look, the third quartile is way more spread out than the second quartile, right? In fact, you could even say something like the upper half of the data, right? Which is this is 50% of your data this way, because that's where the median is. The other 50% is this way. The upper half is significantly more spread out than the lower half, right? These are observations that we can make. There's two other things that we should talk about when you're looking at a box and whisker plot. One is called the range, and that's basically just the actual spread of your data. Our data goes from 2 to 36, and so the range or the spread of our data is 34. But then you have lots of things where you want to know what the inner 50% of your data looks like. What's the range of the inner 50% of your data? And that is called your interquartile range. It's this distance, right? It's from first quartile value to third quartile value. And it's basically saying, what's the range of the box part of the box and whisker plot? In this case, it's 18 because it goes from 7 to 25, and you just find the difference to find what that distance is. All right, let's do another one. Let's find the 5-number summary for the data set that has the same mean, median, and mode as the one that we just looked at. So again, same everything. Everything's the same. The center is the same. But just because the center's the same doesn't necessarily mean the data is spread the same way. And that's what I'm going to try to showcase, with this one. So first we find the minimum and maximum, right? We have 7 as the minimum, 42 as the maximum. By the way, I ordered this. If you're looking at this on maybe it's like a homework problem or it's just a raw data set, you might want to actually order it yourself so that you could find what the median is, which in this case is 13. Because there's an odd number of numbers here. I think there's 11 of them. So here there's 5 on the left and 5 on the right. So you could actually count to what the median would be, which is 13. And I've been plotting these kind of as we found them, just drawing the vertical lines there. I labeled 7 and 13, of course, because that's actually not on the number line. I'm using the same number line that we did last time. Now we need to find the first quartile. Well, because the original amount of numbers was 11, so 13 was the median, which split this thing into two lower half and an upper half, each of which is 5 numbers. That's also odd. So 7. Oh, I drew my box first. I forgot about that. Oh, actually, one thing that I should point out here, and this is, I think this is actually really important. 7 is the first quartile value, but the minimum is also 7. So, normally box and whisker plots will look something like this, where you have real distinct, oh no, that was terrible. You have real distinct box and whiskers, real distinct quartiles. In this one, your minimum value, this thing, is the same as the first quartile value. And so we don't see that. We don't see something like this on this one. The minimum value is here. And the first quartile value is also here. They're stacked on top of each other. And so what you can infer, if you're ever looking at a box and whisker plot that looks like this, what you can infer is the first 25% of your data must all be the same number. That's essentially what that means. And that's exactly what we have in this case. So when I drew this first part of the box and whisker plot, there's no whisker part to start off with. So I just drew essentially the second quartile, the first box of the box and whisker plot, which goes from 7 to 13. But the first quartile is there, it's just all right here. Okay, so something to keep in mind. The third quartile is 35 because it's the middle. There's 2 on the left and 2 on the right. And so I drew that at 35, and then I just kind of completed the box and whisker plot. All right, and just like we did with the last one, I think it's important to talk about the range. In this one, it is 35, which I actually already forgot what our first range was, but I feel like that's higher. I know for sure our interquartile range was higher. I think the other one was 18 or something. This one's 28, right? So this data is actually significantly more spread, which you might have been able to guess just by looking at the min and max. But there you go. What we can do actually now is, because we have 2 data sets that have the same mean, median, and mode, but a different spread, is we can actually compare them by drawing them on the same number line. I don't know why this is yellow, by the way. That has no significance to any of the other of the numbers that I labeled. But here you go. We can kind of compare these two things. The second data set does clearly have kind of a bigger range. It has a bigger maximum for sure. It definitely has a bigger spread, I would say, in its third quartile. Right? Its third quartile is almost the entire spread of the upper half of the data for our first data set, right? This stuff down here is almost exactly the same. But yeah, that's box and whisker plot. I think visually, it's just a much easier way to examine the spread. Now, box and whisker plot, we do get more information than just looking at what the center of data is. But this is still not telling the full story. Like, sure, we get how the spread of each quartile is, but we don't know how each thing is spread within, right, this quartile, right, or within this quartile, or within this quartile. It's possible, like if someone just shows you a box and whisker plot, let's say we have this, but no context at all. Sure, we know what this quartile's range is, but like we don't know anything about the data. Like we could have like 16 numbers between 14 and 16 here, and then one number over here at like 34. Maybe that's what that quartile looks like. We don't know, right? Of course, we do know because we graphed it based on a data set. But I'm just saying, if you just show a box and whisker plot to someone, it's helpful to know what the spread of each quartile is, but you don't actually get what the spread within each quartile is. That's still not known. And that's what we're going to talk about in the next time. We're going to talk about some distributions and some standard deviation stuff with normal distributions. So we'll get there. But for right now, just know that box and whisker plots still don't tell the full story. So I wanted to end with some closing remarks. Most important thing to remember is that median is not included in either half of the data set when you're figuring out a 5-number summary. It acts as the dividing value, which splits your data. So if you have an even amount of things, it's the average of the two things, in which case, of course, the median's not actually a data set value. So it looks like this. Or if it's an odd number of entries, then you have the actual median, but then again, it splits it into two pieces. So you have this half, and we don't include the median in either of them when we're doing calculations after that. The second thing is that the 5-number summary is just a bunch of medians, right? You have a min, a max, a median, and then a median of the first half and a median of the second half of the data. And then finally, it breaks data into fourths, and we call those fourths quartiles. And like I said, there's other ways that we can analyze the spread or distribution of data. A 5-number summary is just one of the ways. It's just the first way that we're kind of examining. All right, so that's it. A little bit of a longer one this time, but hopefully you guys found it informative. Hopefully you guys learned something. If you guys have any questions, please leave a comment below or shoot me an email. Thanks a ton for watching, and I'll see you in the next one.